Thanks to everybody. I feel bad for this podium. I've been sitting out here in the sun trying to do this, right? I feel better. I don't know if anybody else does. So, two great mini presentations here to talk about really a case study in wetlands application. And I'm going to start with what you usually see at the end of a presentation, but everything I'm going to talk about in the next 20 minutes is already up on the website. So I don't see too many note takers. It's a good audience. A lot of times you're in these sessions and people are so busy with their head down taking notes that you don't feel like you're really talking to anybody. So SaveTheRain.us is a great resource for everything we're doing in the program, but this project, no exception. There's probably more information on the site about this project than any other. And in 2011, we created we completed a compensatory storage project, which really was in the area that this project is being constructed. It's a flood zone, and it protects the adjacent neighborhood from the potential of a serious threat of flooding upstream. And to go in and build the berms for the constructed wetland, we had to first create the space for that, and we did that in 2011. It was part of our Project 50, and in 2012 we advanced the actual construction of the project. We've been negotiating with the state on permit limits. That's mostly complete now, and we'll talk more about the specifics of this project. But the plans, the specs, fact sheets, public outreach, everything's up on the website. Please click on the green projects button and you need to go to the appropriate year. I do want to take a minute to talk about the partners here, and I know Sam has been mentioned, as well as Rich and Son. You know, I'm guilty. If I'm guilty of one thing in this program, it's I hope it's trying to listen. And you know, in 2009, we were before the force stipulation had been approved. We're sitting in the large conference room at Metro. I think there was a good 20 to 25 people, and they're trying to figure out what is this revised consent order going to look like? How are we going to solve this RTF problem? And I'm hearing people stand around like, well, well, maybe we could construct that old wetland project that people had been talking about 5 or 10 years. And I'm like, let me write that down. It sounds like a good idea, but it was kind of almost dismissed as a crazy idea. And here we are building it. So it's really remarkable to see that happen. It really is the culmination of going to Sam and saying, they mentioned this project. Tell me more about this, Sam. He's like, well, that was, Jihan Wu and all these other folks that were involved, and I think you should go up and talk to Rick Martin about some of the paperwork that was produced. Go up and I talked to Rick, and we're certainly learning more, but recognizing that it was more of a study. But there had even been a lot of dialogue with the state at the time, and the DEC. So in many places with this program, we've gone where there was momentum. And you can't advance a project without listening and understanding your community, constituents, and collaborating with them and making sure that they are comfortable with the concept and the design. And Rich, I'm going to see you tomorrow night, I think, at the Sun meeting at Monday. So Tara talked a lot about habitat, civic benefits, and Matt just hit on it again. And whether it's fate or good fortune, but I was actually the resident engineer in 1999 when they were expanding the wetland system out of the Manoa wastewater treatment plant. So you sometimes get put into places that you don't know that 15 years later you're going to be immersed in the technology. So the department has been very involved. I mean, they spent a lot of money on this floodplain back in the 90s. And working within the Harbor Brook Basin. The city of Syracuse is certainly somebody we partner with when we're doing these projects and helping us navigate how we might do entrances in and off city streets, etc. And CHA is one of our design partners on this project specifically. But it really takes a number of partners to make a project. In the terms of the GRAY program, this is a small dollar amount and really not that big a project. But in terms of the green program, it's quite a big deal. So that's the overview. We'll talk briefly about performance objectives, a little more about the specifics of the design, but that's all on the website. We'll pull up the plans and the specs some other time. We'll talk about flow control, scenarios, I think, is more interesting. Some construction photos, and really the notable challenges is, I think, where the dialogue is going to go with this group, and I expect it to be quite engaging. So, we talked about the nice thing about having the prior technologists, true designers immersed. I'm just a program manager, right? What do I know about this stuff? So we've been able to drill down to have Professor Martin give some of the side. I know everybody was looking at the formulas that were up there on the breakdown of nitrogen, but at the end of the day, we've got to handle this very physical demand of CSOs, the challenge that Rick mentioned about having no flow portions of the year, sometimes long portions of the year, and then all of a sudden a whole heck of a lot of flow. And how do you handle that? How do you handle that physically? How does the biology adjust to that? And what is the production we're going to get? Are we going to, what is, DEC's very concerned about bacteria, as we all should be. Somebody raised their hand the last time they went water skiing in Harbor Brook. We've got to keep in context the receiving water, and instantly this project is going to have an impact on the water environment in that community. We've got to confirm this project, as we said, from a technical aspect. There's a lot of people nationally and internationally interested in the results. So we will measure that bacteria and how far down it's reduced, and whether or not chlorination, dechlorination will be needed in the future. But first, let's see how it performs on its own, and we're expecting pretty great results. We're going to work. Why do we call this a pilot? It's a full-scale pilot, building the whole thing. It's really about optimizing it. It's going to work. I assure everybody that. It's a question of how well it will work. Are there adjustments in the operation that we can make that'll put out better performance in the future and really set it on a course long term as to the standard operating procedure for dry weather, for wet weather, seasonally. Those are the things we're going to learn. And as I said, a lot of people nationally, and certainly across New York State, are interested in how successful we are in applying this to their communities. So I talked about this as a full-scale pilot. We're not doing this in a laboratory. There's really no way to effectively manage this in the lab and then take it out into the field. We'd be then trying to tweak what we did in the field back to what we did in the laboratory. At the end of the day, the best thing to do is build it. We know there's enough data out there to say it's going to be effective. It's a question of how effective. So let's get into the middle of it and then adjust going forward. Keep the regulators engaged and build a data set. We've done that. We've got some baseline data that initiated back in 2011. Not to mention the work that ASLF and ESF had conducted previously. As I mentioned, the permitting is ongoing. It's part of the entire county metro speedies permit. This CSO is really no different than the rest of them. It just has a unique applied solution for the specific one, and we call it, it's numbered 018, 018, not just 18, 018. I didn't make up all these rules. So, construction, I talked about compensatory storage in 2011. And we're into the pilot construction now. It's going to be completed in around June, and it'll take some time for the plants to establish, and it'll really be into 2014 before we really can both say that we really have a completed project. And in the meantime, we'll be making some adjustments in operation and even seeing how it's doing through the establishment period. And this is a 2-year process. So there's that 018 attributes here. We've got a certain area of that CSO. It's quite large, 145 acres worth of runoff that we're managing. That normally, under dry considerations, the sewer takes it down to Metropolitan Treatment Plant for a high level of treatment. During runoff events, we see as much as 13.6. That number's been, we've done the SWIM model. We've reconstructed the SWIM model in the last year, and the numbers are actually showing it's maybe closer to 14, 15 million gallons a year of runoff. And obviously that comes in spits and sputters based on the rainfall. We need to be able to handle that, but as many as 42 individual sequenced events over the course of a year. So we wanted to, this is in many ways green infrastructure, but it is in many ways like Gray, has a treatment plant design value for volume and a peak rate. It operates in a green manner, but we do traditionally handle that in the Gray manner of a peak flow and an average flow. So folks are probably familiar with the Skunk City neighborhood that is adjacent to the project and downstream of Harbor Brook. We've got some identifying features here, of course, Harbor Brook. Folks will orient themselves maybe by the stormwater control structure that you can get a good view of the basin from by standing over that and looking at our wetlands construction right now. The discharge from the Interceptor Sewer really, the sewer is headed this way, east, and then up towards Metro. The discharge point is right around here, and the outfall from that is right about here, and then trickles down to the brook. So just layering on our plan sheet into that area and showing with the grit and floatable unit. Rick talked about some of the headworks of this facility. We've got to take out the heavy stuff and floating stuff so that we don't contaminate the wetland. And those are really polishing treatment systems as opposed to heavy gray infrastructure. And of course the wetland cells. And it'll discharge really just a few 100 feet from where it always has. So it's really easy to kind of work within this rendering, and this is set within a photograph. So there's that flow control structure and the brook itself. And here's where our construction lies. And it will be enclosed with a fence, and that is really to keep the animal population out, as well as certainly kids, and allow maintenance to go in and conduct their efforts. So this is an early design rendering, but there's been a few tweaks. It's very close to what it'll end up looking like. So we talked about that floating wetland system, and very much with these vegetative mats that are pretty state-of-the-art, and kind of provide somewhat of a hybrid in its ability to treat the water. It has some pros and cons, like all three of these do. Some examples of where this has been applied in other places. The vertical downflow that Tara talked about is pretty typical, and has, again, these pros and cons. That's the middle cell. Closest example I can give you is the Toronto Airport. Has some of this. Wetlands have been used. They're being used in Buffalo as well for treatment of glycol contaminated stormwater. It's a really intense, pretty polluted runoff, and being the wetlands have really been as effective as any treatment technology, Gray alike, in handling that kind of waste stream. So you've got this forebay up here, and then the wetland systems down here. And then our last system, as Terry mentioned, most closely resembles a natural wetland with robust native species, and it'll probably provide the best habitat for birds and other species. And I think we've seen a few photos similar to these two earlier today. So the cells themselves, the previous table is about the watershed. This is about the system itself, the area, the depth. Look at the depth we have here. We've got in the floating wetlands anywhere between 0.3 and a foot. As the storm comes in, that flow will oscillate up and down. We have no standing water in the vertical system, or at least nominal, and the surface flow will be about half a foot down to almost nothing. Just enough to keep the system hydraulically wet. The plant's happy during those periods of dry, extended, prolonged dry periods in CSO frequency. And so, and we come up here, here's the maximum depths. I'm sorry, I'm looking at the metric in the English, but here's our maximum depth. So that fluctuation in that floating level is 4 feet to 1 feet. And the 1 feet is really to give that growth, the root structure in that floating wetland enough happiness. And then again, the surface of 1.5 to 0.5. So we've got about a foot of fluctuation in the hydraulics. All the side slopes are the same. And you can see those side slopes today if you go out and visit the site. These are the treatment expectations. We are getting reduction in bacteria. Phosphorus is orders of magnitude or an order of magnitude better. TKN, we think that these are conservative, and we have expectations for the system to be pretty high performing up above. The bacteria will be the challenge, to be quite frank with you, and we'll see how we can work to find the right level of service for this water body. So the real cool thing is, how do we actually route flow? And we talked about that, headworks, flow diversion structure, and then how we route it through the wetland system. So in series, we've got the flow basically coming into cell 1, goes into cell 2, and into cell 3 and out. It's pretty straightforward. Okay, and I guess we got a latent arrow there. But parallels, where we get the opportunity to go out and tweak some valves and operate this a little differently. We can bring it into cell 1. Then we can split the flow from cell 1 into cell 2 and 3. That gives us a bit of a different, in a high flow situation. We got to put more water through the system, so we kind of split it into two systems as opposed to going in series through basically one train. Now I've got 2 trains. And we can even hybridize this, and we may find this through this pilot and optimization period. We may split some of the flow and bypass some of it into cells 2 and 3, but allow some of it to go from 1 to 2, and really provide the optimum performance that we're looking for. And we may do this under certain flow regimens or seasons, and flip back during others. So up above is a photo sim. This is actually a number of digital photos stitched together. This is the newest rendering of the site, and then it's superimposed into the area. And again, you can see the flow diversion structure up here, and how this is intended to blend in with the berms and in the low-lying area. And here's that compensatory storage area. I think it's as much as 6 inches deep down on that side of the system, but we took out enough dirt to compensate for the berms that were creating the wetland cells. So just wrapping up here with a couple of photos. This is almost the same point of view I took those previous photos from. So here's our flow diversion structure in the brook running through this dense phragmite zone. So here's cell 1, cell 2, and cell 3. You see some of the scale of the depth here. We've got a car to give some perspective. People standing in here, and some Compensatories reaching down, pulling off the dirt for the berms. Here's a zoom in. You see the size of the system. And that's cell 2 and cell 3. And today, if you go out there, you'll see some of the soils that are being put into there, and some of the one item I will say is this wetland has been diverted. There used to be a wetland that cut naturally through here, and would be diverted around the outside of the berm, a little to the east, and then further to the north. So we intend to create a viewing platform because of the berm and the fence. We want to give the opportunity for the community to observe, particularly the surface cell and some of the habitat that's been created, and some of the performance, how this is operating during storms. We've probably got to build up a little bit of a platform for people to observe this and see a little bit over the fence, and really create an outdoor classroom. And we're going to work, actually that's one of the topics of conversation with the Skunk City neighborhood and tomorrow night's meeting. So that's something, and also, what is the interaction between this site and the community at large? I know there was a master plan that the EDR completed, and we've reviewed that and understanding the context of the Skunk City neighborhood and their access along the Roland Street, really dirt road and maintenance road, and the neighboring Western Lights shopping areas. So these are some of the frequently asked questions. I think that'll kick us off into a pretty good discussion. Hopefully I did okay on time, and I'll turn it back over to Matt.